Hi, good day. Welcome to my channel again. Happy to see you, everyone. Again, this channel is intended for those who are struggling and those who want to learn more about mathematics. So, once again, I will welcome all the subscribers to watch me in my videos about mathematics. So, again, this is Alice Apale alias Emma Watson. So, no, you are now in my channel. So please don't forget before you start the video, kindly click the subscribe, the yellow bell button so that you will be notified um, once another or new video will be uploaded in my YouTube channel. At least you will be updated to my channel. Okay, so do not forget to subscribe and share. And of course, you can comment if you have some concerns regarding with the lesson or video discussion. So are you ready? I hope everybody is ready. So before anything else, I would like to shout out all the people out there. Hello, everyone, especially the students from Davao City National High School. You're all bright people. What about the other school? Santa Ana, hello, Santa Ana National High School also. And to all of schools here in Davao City who are doing the online classes, this channel is for you. If you want to learn, then just subscribe my channel, then click subscribe, the yellow bell button, and also you can share it to your friends, especially those who need help to learn about mathematics. This video will guide you to answer all your modules in math. Who are enjoying the modules there out there? I know everybody is doing the modules. I know that. And I know that you are having fun answering and doing all your modules because math is fun. So math is interesting and it is more fabulous than the other subject. So sorry for bias because I love math because I'm a math teacher. Okay, so now um, going to our new topic for this video discussions. I guess you have the idea what it is. Do you have? Hmm. What do you think is our next topic um, this session or in this session rather? What do you think? I'm thinking also what will be the topic that we have to talk about this in this session. Ah, can you now remember? Oh, I hope you'll be able to remember the things that we have just discussed in the previous topic about operations on set. But this time, we will be talking about the sets in a Venn diagram. So this is my PowerPoint presentation for this afternoon's session. I hope everybody will be able to be active to activate their skill, their math skill, and will be able to develop your critical thinking skills in this topic in the video discussion because this topic is something like abstract. Let's just enjoy the drawings. So as I have said, our topic will be something like related to the drawing or the diagrams as posted on the screen. You have the union of A and B, the Venn diagrams, intersection of A and B, difference A minus B, difference B minus A. So do you have any idea about our main topic this video discussion? You have the idea. Let's see if your idea is the same as the topic that I will be posting here on the screen. Let's see. Sharing. Okay, so our topic for this session will be about set Venn diagrams. So again, our topic will be related to set Venn diagrams. So are you ready? If you're ready, say let's go. Okay, let's go. So to start with, of course, I have to introduce the different Venn diagrams used in the set. So here are the Venn diagrams. So as you can see there in the figure class, the A represent or this diagram or Venn diagram shows A or set A. So you can just shade, the shaded part rather describes the notation below the diagram. So the shaded part, this one, the shaded part, that is set A. For the second one, this one, the shaded part, that's set B. And for this diagram, as you can see, I want you to focus on the shaded part. So the shaded part here are these outside A, the shaded part, okay? The color yellow, I want you to focus on color yellow. That means complement of A. So can be written in this notation, the one that I encircled. Okay, another thing also below. So this one, the shaded part, the color yellow. This one, the color yellow, as you can see, this represents or this describes or this Venn diagram, the shaded part describes as complement of B. Okay, in this Venn diagram, the shaded part, this one, the shaded part, including this one. So the shaded part in here in the Venn diagram describes the union. So A union B. You read this one as A union B. Do not forget how to read it correctly. Another thing also, class, this one, the last shaded part, that refers to their common elements. So the shaded part, the color yellow here at the center, that describes an intersection. So the symbol is here below, the one that I encircled. And you can read that one as A intersection B. Okay, or A intersect B, another term. So these are the Venn diagrams, the basic thing that we can represent, or the operations or the some concept of sets or operations on sets can be represented in these Venn diagrams that I have, that you can see on the screen or projected on the screen rather. Okay, so please do not forget it. You can just put the illustration or write it in your notebook so that you'll not forget it. So again, for set A, that's the diagram. I want you to focus on the shaded part, the color yellow. For B, the color yellow, that's the set B. And complement of A, complement of B, A union B, and A intersect B or intersection B. Okay, so now let's define first what is a Venn diagram. So Venn diagrams, as you can see there on the screen, that means, or it is being defined as, or it shows logical relations between a finite collection of sets. Again, the Venn diagram class, we define Venn diagrams, or it shows the logical relationship or relations between a finite collection of sets. So if you want to describe the relationship of the sets, then you can represent it, or you can use the Venn diagram to represent their relationships. When we talk about sets, that's why Venn diagrams has its own use in the set theory. Okay. So another thing also, excited. Another thing also, I want you to remember to represent, I've shown this one a while ago. Let's define and have, and try to define it, describe and define the following terminologies related to the operations on sets. When we say union of set, that means again, consists of all elements in sets A and B. So that can be represented in this notation, A union B, and also can be described in this Venn diagram. So I want you to focus on the shaded part, the color blue in the Venn diagram. That represents the union. What will be there, what will be part in the shaded region are all part of the union of the two sets. Another thing also that I want you to remember in the operations on sets, aside from the union, is the intersection of sets. So when we say intersection of sets, that means consists of only the common elements in sets A and B. Again, common elements in sets A and B. That's intersection. It can be represented by this symbol A intersect B. And the shaded part in here at the center represents the intersection of sets. Another thing also that we need to remember, terms related to operations on sets, is the term complement of set. When we say complement of set, as you can see there, it consists of elements which do not belong to set A. Again, our shaded part will be our focus in the Venn diagram, the color blue. So a complement of set can be represented or can be symbolized or denoted by these symbols. So there are three. Last videos, I just introduced two. This one and this one, but there is additional. So these are just the symbols. There are a lot of symbols in set theory, since set theory belongs to higher mathematics topics. So now, so what is outside A or does not belong to A, that is the complement of the set A. So again, the shaded part, the color blue, that's the complement of set A. Next is very not familiar with you. We call it the difference of set. It's not just the normal difference of sets that we have talked about in sets. What is symmetric difference of sets? So when we say symmetric difference of sets, it consists of elements in sets A and B, but not in the intersection or in their intersection rather. Again, I'll repeat. When we say symmetric difference of sets, that means consists of elements in sets A and B, but not in their intersection. So these are the symbols used for the symmetric difference of sets, as you can see. And also the Venn diagram shows the symmetric difference of the two sets given. So again, focus on the shaded part, the color blue. That is the symmetric difference of the sets. So these are the importance or use of Venn diagrams in the sets, in the set theory, because it gives us the idea to illustrate, since as what I said a while ago rather, the sets or the concept of set, it's too abstract, especially in operations. So meaning to say, since it's abstract, we need something to represent on in order to understand the concept, and that is the Venn diagrams. Again, the use of Venn diagram is to show the logical relationships between a finite collection sets of data or collection of sets. Okay, so I hope you can follow. So using the Venn diagrams in union of sets, though we already tackled that one a while ago, but to highlight, just to highlight so that you will not forget it. Okay, the union of sets using the Venn diagram. I'm so sorry with that. Let's have an example. Wait, so I cannot circle. I'll erase and clear first. So let's have A. Set A consists of elements A, B, C, and D. Set B consists of elements C, D, E, and F. So the A union B is equal to, of course, A, B, C, D, E, F. This example shows our elements or the sets overlap. Why overlap? Because your D repeats twice. It repeats twice. What I mean, there is a duplication of the element in both sets, the D. That's why sets overlap. So when you get its union, of course, you take it as one, the one that repeats more than once, or the one that repeats rather. So the answer for A union B is A, B, C, D, E, F. So this can be represented using the Venn diagram, as you can see on the left side of the problem. Another thing also, another example for the using the Venn diagram, of course, in the union of sets, we have set A, A, B, C, D, and we have it X, Y, Z for the elements of set B. So now, when we get the union of A and B, or A union B, which is equal to A, B, C, D, X, Y, Z, can you see or are the sets overlap? Are the sets overlap? Did they? No, they did not. But the sets are disjoint. They don't have common. As you can see, it can be illustrated there on the Venn diagram, as you can see on the screen. So this one, the first example shows how sets overlap in the union of sets. And also the second example shows how sets are disjoint in the union of sets. So this is very important concept, especially in probability. Okay? So I want you to remember that one. Another thing also, if we have the representation of union of sets in a Venn diagrams, we also have the second operations on sets using the Venn diagram. We will illustrate it using the Venn diagram rather. We have the set intersection. So as what I've said, when we say intersection, that means the common. What's the common between the two sets? So to illustrate, we have at A consists of A, B, C, D. For B, we have A, B. Then if we get A intersection of B or A intersect B, then that gives us B, since B is their common element. So as you can see in the Venn diagram, see, A and B is at the center. So I want you to remember that one. Another thing also that I want you to remember, the example number 2. When we have A, set A consists of elements A, B, C, D, and B consists, or set B consists of elements X, Y, Z. So when we get its intersection, it's so obviously rather, very obvious that their intersection is a null set because there is no common elements between the two sets. Correct? And it can be represented in this Venn diagram. See, there is no intersection unlike in the example number 1. So that's how you represent a set intersection using the Venn diagram. So a complement. So when we say complement of a set, that means again elements that do not belong to A, as illustrated here on the screen. Example on the screen. So what is shaded there, that's your answer. That's the complement of A. Those are elements that do not belong to A. And that's how we illustrate a complement of a set using a Venn diagram. So I hope you'll be able to grasp the concept and will be able to retain all the things that we're talking about here. So set difference. When we say set difference, according to the definition last time or last videos that I posted, it is the difference of two sets A and B denoted A. This one, this is also this symbol, the one that I encircled. This is the symbol or another symbol for the difference of two sets. So do not be confused if you encounter this symbol. Of course, this very popular symbol, common symbol that is used for the set difference, the A minus B. So again, that means that it is the set containing those elements that are in A but not in B. In B, what I mean in A but not in B, just like here. In A but not in B. So that's what we call set difference. So the set difference can be represented by this Venn diagram. So I hope you'll be able to realize and will be able to know how to use the Venn diagrams in illustrating or describing the operations on set, especially the concept of set. So always remember, if you have the knowledge about this one, it will be easier for you to communicate with the symbols and also, of course, with the lessons that we have, especially in the set theory. It has full of or a lot of symbols that you have to be familiar of. So that's it. I hope you will be able to learn another thing or new things in this video discussion. So see you next meeting or next video discussion. Thank you so much for subscribing and for watching until the end of this video. So please do not forget, if you like the video, if you learned something, share it to your friends, to your families, or to your FB friends, Twitter, Instagram, and etc. And aside from that, please do not forget to subscribe and then click the the yellow bell button in order for you to be updated and you'll be able to, you will be notified rather once there is a new video that will be uploaded in my channel. Okay, so thank you so much for listening. Have a good day, everyone. Thank you.